Today we have the question which says calculate the escape velocity of a satellite from the Earth's gravitational field. They gave us hints small g, which is acceleration due to gravity, 9.8 meter per second squared. Then the radius of the Earth as 6.4 times 10 raised to power 6 meter. Now, please, what is escape velocity and what formula are we going to use to solve this question? Escape velocity is actually defined as the minimum velocity with which an what object would just escape from the influence of the Earth's gravitational field. Now, it is not just only Earth. Imagine this to be a planet. Let's take Earth, for instance. Now, we have objects that are on the surface of the Earth. Now, let's take, for instance, an aeroplane. Let's take, for instance, an what? Aeroplane. Now, the minimum velocity, from what I said, the smallest velocity for this aeroplane to escape the gravitational influence of the Earth is what? Escape what? Velocity. So you know that every object on the Earth's surface, if you jump up, what will happen? The Earth will what? Attract you due to what? Force of what? Gravity. So we know that from our universal gravitation that we discussed earlier, we were able to see that the Earth has a very big mass, which are around 5.98 times 10 raised to power 24 kilogram. So it makes a lot of sense for the Earth to attract objects that are on the surface of the Earth. When they try to leave, the Earth will try and attract them. So, but now we are discussing escape velocity. We said that escape velocity is the smallest velocity for this object, aeroplane in question, to do what? To escape that dragging force of the Earth, that acceleration due to what? Gravity. Do you understand it? And this escape velocity sometimes represented, okay, velocity. So let's see it as V subscript E, escape velocity. The formula is given by, it has two formulas. The first one given by square root of 2gr. And the second one given by escape velocity is equals square root of 2gm all over r. Please, you'll be asking, when am I going to use this formula and when am I going to use this one? Be very much careful. I will explain here. Now, this small g means acceleration due to gravity of the astronomical body, that's of the Earth, of the other planets. Is that clear? Now, this R, big R, means means radius of the astronomical body. This R. So if it is the Earth, we consider the radius of the what? Earth. If it is Jupiter, we consider the radius of Jupiter. If it is Saturn, we consider the radius of what? Saturn. Please, it is not the radius of the object that is leaving the influence of a particular astronomical body. It is not the radius of the satellite, rather the radius of the one that we assume to attract. That's the one that has big mass. In this one, it should be Earth. Now, I've explained this one. Now, here, what we are having is square root of 2gm all over r. Now, by now, you should know this if you've been following me. Capital G is universal gravitational constant. Universal gravitational constant. This mass, bigger mass, it is not the mass of the object that is leaving. It is actually the mass of the what? Astronomical body. The one that is meant to what? Attract. The bigger one. So in most questions, these people, they will confuse you by putting the mass of the object that is what? Leaving. Now, give you the that's the constant, universal gravitational constant. Then equally give you the radius of the bigger planet. Now, if you ever use this formula in that case, that's giving you the mass of the object that is living, and you think that you are meant to use this, it is a very big what? Lie. Please be careful. I hope you're following. So, what I want to do now is I have to solve this what question. So, if you want, calculate the escrow velocity from the Earth's gravitational field of a satellite from the Earth. Now, watch out. They gave me the radius of the what? Earth. They gave me the what? Acceleration due to gravity on the Earth. So it means that I'm going to use the formula. So I have that VE is equal to square root of 2 times 9.8 times what? 6.4 times 10 raised to power 6. Is that clear? So if I solve this, acceleration due to gravity, 2 times 9.8 will give me what? 2 times 2 times 9.8 is equals 19.6 times 6.4, it gives me 125, give me 125.44 times 10 raised to the power 6. So you have to just find the square root of it. So I have to find what's the square root of 125.44 exponential 6. So the answer is 11,200. So since it's velocity, the unit will be meter per seconds. And that's the final answer. Have a nice day. Like, comment, share, and follow Courses Academy. Bye bye.